thought Saturn was the calm one, the elegant one, the planet you show in textbooks when you want to remind people how beautiful the universe can be. Perfect ring, soft colors, smooth bands of clouds. If Jupiter is chaos, Saturn feels like balance. But those rings are billions of fragments moving faster than bullets. And beneath those clouds, there is no surface. Only layers that get hotter, denser, and harder to escape. And if you go too deep, there's a point where turning back stops being an option. Not because something explodes, but because the physics quietly takes that option away. Saturn has always had a reputation problem. Not because it's dangerous, but because it looks too perfect. When early astronomers first observed it through telescopes, they didn't even understand what they were seeing. Those rings didn't make sense. They looked like handles or ears, something attached to the planet. It wasn't until Christian Huygens in the 1600s that we realized Saturn was surrounded by a thin, flat ring system. And ever since then, Saturn became the symbol of beauty in the solar system. Not danger, not chaos, beauty. But that image hides what Saturn actually is. Because Saturn is still a gas giant, just like Jupiter, which means one very important thing. You cannot land on it. This is where most people underestimate Saturn. Because when you look at it, your brain automatically assumes there's something solid underneath those clouds. Something you can stand on, even if it's far below. But that's not how Saturn works. If you approach Saturn, the first thing you'll notice is how massive it is. Saturn is about 9 times wider than Earth. And despite being less dense than water, it still has 95 times Earth's mass. That means its gravity is real. Not as extreme as Jupiter's, but more than enough to pull you in. Now here's where the story actually begins. Because getting to Saturn is one thing. But what happens when you try to interact with it? That's something else entirely. Let's say you try to descend. At first, it wouldn't feel that different from entering Earth's atmosphere. You pass through the outer layers of gas. Hydrogen, helium, trace amounts of methane and ammonia. The colors around you would shift pale gold, soft yellows, subtle browns. Almost peaceful. But that calm doesn't last. Because Saturn's atmosphere is not still. It's moving. Vast. Wind speeds on Saturn can reach over 1,800 kilometers per hour. That's more than 4 times stronger than the most powerful hurricanes on Earth. And these aren't isolated storms. They wrap around the entire planet. Continuous, global, relentless. And here's something most people don't realize. Saturn has a storm at its North Pole that doesn't exist anywhere else in the solar system. A perfect hexagon. Yes, a 6-sided storm. Larger than Earth. Stable. Persistent. First discovered by the Voyager missions in the 1980s and later studied in detail by the Cassini spacecraft. This hexagonal storm rotates around Saturn's North Pole with wind speeds exceeding 300 meters per second. No one fully understands why it exists in that shape. Fluids don't naturally form perfect geometric patterns like that. And yet, there it is, locked in place. Now imagine descending through that atmosphere. You're not just falling. You're being pushed, pulled sideways, dragged into currents moving faster than anything we've experienced on Earth. And the deeper you go, the thicker it becomes. At some point, you stop thinking of it as air, because it no longer behaves like air. It starts behaving like a fluid. Dense, heavy, resistant. Your descent slows, not because you're safe, but because Saturn is beginning to hold you. And while that's happening, the temperature starts rising. At the top of Saturn's atmosphere, temperatures can drop to around minus 180 degrees C. Cold enough to freeze almost anything instantly. But Saturn has a strange characteristic. The deeper you go, the hotter it gets. And it doesn't increase slowly. It accelerates. a few hundred kilometers down. You're already dealing with temperatures that can destroy most materials. Deeper still, you're entering regions where temperatures climb into the thousands of degrees. At the same time, pressure is building exponentially. On Earth, we measure pressure in atmospheres. At sea level, you're at 1 atmosphere. At the bottom of the Mariana Trench, you're at around 1,000 atmospheres. Saturn doesn't stop there. It keeps going to millions of atmospheres. Now here's where things start to change in a way that's hard to imagine. Because under those conditions, hydrogen stops behaving normally. At first, it compresses into a liquid, an ocean of liquid hydrogen, stretching thousands of kilometers deep. And then, it becomes something else entirely. Metallic hydrogen. This is not science fiction. Under extreme pressure, hydrogen's electrons break free. It starts conducting electricity. It behaves like a metal, which means deep inside Saturn, there is an ocean of liquid metal. And inside that layer, Saturn generates its magnetic field, a massive, invisible force that extends far into space. But here's the part that matters for you. By the time you reach this depth, you are no longer in a position to leave, because everything is working against you. Gravity is pulling you down. The atmosphere is resisting your movement. The pressure is crushing you, and the temperature is destroying any structure that could survive. Even if somehow your spacecraft remained intact, you would face another problem. You have nothing to push against. On Earth, rockets launch from solid ground. On Mars, the same. Even on the Moon, there is a surface, a reference point, a place to generate thrust. Saturn gives you none of that. You are suspended in a medium that becomes denser the deeper you go. Trying to escape would be like launching a rocket from the bottom of an ocean. Except that ocean is thousands of kilometers deep, and getting heavier and hotter. The deeper you go, the more fuel you would need to escape. And here's where physics steps in. Because fuel has mass, and mass increases the energy required to escape, which means you need more fuel, which adds more mass, which requires even more fuel. It's a loop, and eventually, that loop breaks in one direction. You don't have enough, and that's the point the hook was talking about. Not a sudden explosion, not a dramatic failure, a quiet realization. You've gone too deep, and there is no longer a path back. But here's the part that makes Saturn even more unsettling. All of this is happening beneath something that still looks beautiful. From orbit, Saturn doesn't show any of this. You don't see the pressure. You don't see the heat. You don't see the metallic hydrogen oceans. You see rings. And those rings might be the most misleading feature in the entire solar system. Because from a distance, they look solid, smooth, almost like a disk. But they're not. They are made of trillions of particles. Ice, rock, dust. Some are as small as grains of sand. Others are as large as mountains. And they're all moving. Vast, orbiting Saturn at speeds of up to 30,000 kilometers per hour. Now imagine trying to pass through them. You don't glide. You collide. At those speeds, even a small fragment can cause catastrophic damage. And larger ones would completely destroy anything in their path. But here's the strange part. The rings are incredibly thin. In some places, only about 10 meters thick, which means Saturn has created something that looks massive, but is actually fragile, a structure that exists on the edge of stability. And it won't last forever. Saturn is slowly losing its rings. Particles are being pulled into the planet over time, a process known as ring rain, which means the most iconic feature of Saturn is temporary, and that adds another layer to the story. Because Saturn is not just dangerous, it's changing, quietly, slowly, losing parts of itself while still appearing perfectly stable from a distance. And that's the theme that keeps coming back. Saturn doesn't show you what it really is. It lets you believe it's safe. Until you get closer. Until you go deeper. Until you reach the point where leaving is no longer possible. And we haven't even left the planet itself yet. Because once you start looking beyond Saturn, into its system, you begin to realize that Saturn is not just a planet. It's part of something much more complex. Something that might be hiding environments even stranger than the planet itself. Saturn doesn't exist alone. And that's where things start to become even more unsettling. Because if the planet itself is a trap, its surroundings don't offer much escape either. Saturn is surrounded by over 140 known moons. Some small, some massive, and a few of them are more active than entire planets. Now at first, that sounds like a good thing. If Saturn is too dangerous to approach, maybe you could stay near one of its moons instead. Use them as stepping stones. Safe zones. That's what we always imagine. There's always somewhere to land. Somewhere to regroup. Somewhere to survive. But Saturn's system doesn't really work like that. Let's start with one of the most famous moons. Titan. Titan is larger than the planet Mercury. It has a thick atmosphere. Lakes. Rivers. Even rain. For a moment, it sounds like a better version of Mars. More stable. More protected. Almost habitable. But then you look closer. Titan's atmosphere is mostly nitrogen, with a heavy mix of methane, which means those lakes, they're not water, they're liquid hydrocarbons. Methane, ethane. At temperatures around minus 180 degrees C, water doesn't flow on Titan. It's rock, solid. So instead of water cycles like Earth, Titan has a methane cycle. Clouds form, rain falls, rivers carve the surface. But it's all happening with chemicals that would be toxic to us. And the atmosphere is so thick that sunlight barely reaches the surface. Everything is dim, orange, hazy. Now here's where Titan becomes more than just strange. Because beneath its frozen crust, there may be a subsurface ocean. Liquid water, hidden, protected from the cold above. Which means Titan has two things scientists pay attention to. Liquid and chemistry, the same ingredients that made life possible on Earth. And that raises a question. Not is there life on Titan, but if there is, what would it even look like? Because it wouldn't be like anything we know. But Titan is just one piece of the system. Now let's move to something much smaller, much colder, but far more violent. Enceladus. At first glance, it doesn't look like much. A small icy moon. Bright, smooth. But in 2005, something unexpected happened. The Cassini spacecraft flew past Enceladus and detected something erupting from its surface. Geysers. Massive plumes of water vapor shooting into space. Not just small bursts. Columns stretching hundreds of kilometers above the surface. Which means something underneath is pushing that material out. Heat, pressure, energy. And when scientists analyzed those plumes, they found something even more interesting. Organic molecules. Not life, but the building blocks of life. Carbon-based compounds. Salt. Chemistry that suggests interaction between water and rock. In other words, conditions that look very familiar. Conditions we associate with life. And just like that, Saturn's system changed. Because now we're not just talking about a gas giant. We're talking about a system that might have environments where life could exist. Hidden beneath ice. Protected from radiation. But here's the uncomfortable part. If something does exist there, it exists in total isolation. No sunlight, no surface world, just darkness, pressure, and chemistry. Now think about that for a second. because earlier, Saturn itself was described as a trap, a place you fall into and can't escape. But what if that idea applies to its moons too? Not in the same way, but in a different form. Because if you were on Titan, you're not leaving easily. The atmosphere is thick. Gravity is lower than Earth's, but still significant. And temperatures are so low that materials behave differently. Fuel systems, engines, electronics, everything becomes harder to operate. And if you were on Enceladus, you're dealing with extreme cold, surface instability, and a constant bombardment of particles from Saturn's magnetic field. Which brings us to something we haven't talked about yet. Saturn's magnetosphere. It's not as intense as Jupiter's, but it's still massive. A region of space filled with charged particles trapped by the planet's magnetic field. Radiation, energy, invisible forces moving at incredible speeds. And these particles don't just stay around Saturn. They interact with its moons. They strike surfaces. They alter chemistry. They create environments that are constantly being modified. So even if you stay away from the planet itself, you're still inside Saturn's influence, still inside its system, still inside its reach. And that's the pattern that keeps showing up. There is no truly safe place here. Not the planet, not the rings, not the moons. Everything is connected. Everything is affected. And everything is more extreme than it looks from a distance. Now let's go back to Saturn itself one more time, because there's something we haven't fully addressed. Why does Saturn feel more unsettling than Jupiter? Jupiter is louder, more violent, more obvious. You look at Jupiter, and you immediately understand the danger. Massive storms, extreme radiation, chaotic atmosphere. It doesn't hide anything, but Saturn does. Saturn presents itself as stable, balanced, beautiful, and that changes how we think about it. It lowers your guard. It makes you believe that maybe this one is different. Maybe this one is safer. But it is, because Saturn doesn't rely on obvious destruction. It relies on something else. Gradual inevitability. You fall in. You descend. You go deeper. Nothing dramatic happens. Until suddenly, you realize you've passed a point you can't come back from. And by then, it's already too late. That's what makes Saturn different. It doesn't fight you. It absorbs you. And everything about it is built to make that process irreversible. From the lack of a surface, to the increasing pressure, the dense layers that resist escape, to the system around it that offers no easy refuge. It's all connected, and it all leads to the same conclusion. Saturn is not the calm one. It's the quiet one. And sometimes, the quiet ones are the most dangerous, because they don't warn you. They just let you come closer, and closer, and once you're in, there's no dramatic ending, no explosion, no final moment, just a slow descent into a place where the rules stop working in your favor. And that's why Saturn is more unsettling than Jupiter. Not because it's stronger, but because it's designed in a way that makes escape feel possible. Right up until the moment it is.